have this question: find the two partial derivatives of each function. The first one, we have this. So that's very simple. We're going to differentiate that respect to the x. The first variable is a function of two variables. We are doing partial derivative respect to x. You keep your y constant. So in that case now, we differentiate this one, and that will be what? 2x. Okay? And the second one, respect to y, you keep your x squared constant, and then you differentiate the exponential function, okay, times 3, and that will give you this. So let me buttress on the derivative of the exponential function. That same question times what? Derivative of the power. Yeah, the b part is a natural logarithm. And one thing you have to note, okay, derivative of natural logarithm of f of x is going to give you derivative of the composite function over the inner function. So that is how to differentiate natural logarithm. So for this case now, it's going to be equal to what? We are doing respect to what? Respect to x. Okay, and that will be equal to derivative of this one. That will be half. This half will go to the front times this one times derivative of the inner function respect to x. That's what? That's 4x all over the function itself. So that's how to differentiate respect to x. So then the next thing to do now, 2 here 1, 2 here 2. So we have 2x all over this one. If this one come down, it becomes so times 1 over this one. Forget you have divided by this one. So you're going to flip upside down to give you this one. So your answer in this case will be equal to what? 2x over for the second variable. Okay, and that will be the same way also. That will be g of y will be equal to, do the same thing also. It's going to give you half the function, the inner function, minus half times derivative of the inner function. That's our times 2y over the function itself. So this one and this one we cancel. So you're going to have the two partial derivative for this function. That's the two partial derivative. So when you are being told to find the two partial derivative, okay, it means you differentiate respect to the first function, you differentiate partially respect to the second function. And that's that on this. At this point, kindly smash the watermarks on this video. Okay, hit that notification bell so that you can get notified anytime I upload new. Don't stop there. Click on like button and begin to type your comments. Share the links of this video on all your social media platforms. Thank you for doing that. Yeah, for the C parts, the first one is going to be, I'm going to keep this one constant. I will differentiate this one. And the derivative of sine is cos of the function times the derivative of the inner function respect to what? Respect to x, which is what? That. Then respect to the second variable. So it's going to be, I'm going to differentiate this one and keep this one constant. Then plus, keep this one constant and differentiate your sign, which will be cos of the function. Okay, times the derivative of the inner function respect to y, which is also what? Times 1. So it has no effect. So that's your answer. Yeah, for the d parts, we have this f of x comma y equal to integral of the upper limit is y, the lower limit is what? Is x of this expression, and then plus is x, the lower limit is y of this expression. Okay, so let's set in the partial differential. This aspect has been dealt with. We have a lot of questions of these on the playlist. This is derivative of integrals. Endeavor to check the playlist for derivative of integrals. for more of these questions. And when we are doing this, we expect the variable here to be the same as the upper limit. But in this case now, this same variable is at the lower limit. So we're going to force it to follow that condition. We're going to move this lower limit to the upper limit, okay, and bring this one down. Another thing again, when you are doing partial derivative respect to certain variable, in this case respect to x, the y variable will be a constant. So we're going to have now minus will comes in y because lower limit to come up. So minus d the x, and this one they're already the same thing. Okay, and this one is what? It's a constant. Okay. So we now have minus. Then begin to substitute now. Don't forget your minus here. Your t, you put your x there. Now we got to what? 4x minus 1, then plus. And when you see your t, you put your x there. 4x plus 1. So open this bracket. So we have minus 4x minus minus, that's plus 1, plus 4x plus 1. And for this one and this one, we cancel. Okay, so that's that on the derivative of integrals. Okay, let's get the respect to y. That will be del y of the function. What you have here, the variable here is y, must be the same as the upper limit. Once it's the same, you just substitute whenever you see t, because it's respect to t, you substitute your y there, and that will be equal to what? 4y minus 1. Here, we are going to force it to be the same. That will be plus. If I'm forcing it now, minus 2 comes in. Then you can now swap the upper and lower limits. That'll be y here, that'll be x here. Okay, so then you can do your substitution. We have 4y minus 1. Then here also substitute. That'll be what? That is minus here. So open your brackets. That'll be 4y plus what? Plus 1. That will give you y minus 1. This one times this one, minus 4y, then minus 1. So that's giving us minus 2 as the answer. So that's that on this. On the final one, for the e parts, we have this. So the first one, do that respect to x. What we're going to do is this variable, is it the same with this one? No. Okay, but it's the same with the lower limits. So we're going to make it to be the same. And by so doing, minus will come in, and then we have this. You swap the upper and lower. So this one will come up, this one will come down. It's to begin to substitute your wherever you see your t, you put x there, and that will be equal to 1 plus 2x cubed. So that's that for that. When you are doing respect to x, when you are doing partial derivative respect to x, your y is what? Is constant. So that's that on that. Let's do the respect to y. Don't forget your minus that is here. So do differentiate that respect to y, your integral, which is equal to what? The upper limit is this, the lower limit is this, and then we have the functions. So once this variable here and here is the same thing, this is a constant because you are doing partial derivative respect to y. X will be constant. So you just substitute wherever you see your t, you put your y there, and your answer will be what? 1 plus 2y cubed square root. And that's that. And I want to remind us this course, this is an advanced class. This is for university students, okay, and other lovers of mathematics. So please check the playlist of Calculus 3 for more videos on derivative of integrals. Okay, I want to thank my viewers across the globe. They are watching me for the first time. Kindly smash the watermarks on the video and hit the notification bell so that anytime I upload, you get notified. Click on like button and begin to type your comments. Don't stop there. Click on like button and begin to share the video, share the links of this video on all your social media platforms. Thank you for doing that.